Okay, so today we're going to work on the review for test number 6. So let's take a look at the first one. It says, name the quadrant or quadrants where each of the angles would terminate in, where they would fall. All right, so we have cosecant theta is greater than 0. So that means, remember when we have cosecant, we want to think of sine. Sine is greater than 0. So I'm looking for where sine is positive. So remember our saying, all students take calc. So that means in quadrant 1, everything's positive. In quadrant 2, sine is positive and cosecant is positive. In quadrant 3, tan is positive and cotangent is positive. And in quadrant 4, cosine is positive and secant is positive. All right, so which quadrant or quadrants is sine positive or cosecant positive? That would be quadrants 1 and 2. All right, so let's take a look at letter B. So I'm looking for sine to be less than 0, so I'm looking for sine to be negative. And tan to be greater than 0, that means I'm looking for tan to be positive. In which quadrants is sine negative? Sine is negative in quadrants 3 and 4. Tan is positive in quadrants 1 and 3. So where is sine negative and tan positive? That would be quadrant 3. All right, let's look at the next one. So we have cosecant, so we're going to think of sine, positive, greater than 0. And cosine is negative, less than 0. So which quadrants is sine positive? Sine is positive in quadrant 1 and 2. And cosine is negative in quadrants 2 and 3. So where is sine positive, cosine negative? That would be quadrant 2. All right, so let's take a look at number 2. How do we change from degrees to radians? So to change from degrees to radians, so let's write this down. To change from degrees to radians, you put with pi over 180 and then you reduce the numbers. All right, so 220 degrees would be 220 pi divided by 180. So what we would do is we would reduce 220 and 180. So 220 and 180 reduce to 11 over 9. So it'll be 11 pi over 9. Okay, 585 degrees. So it'll be 585 pi divided by 180. So I would reduce the 585 and 180. So 585 and 180 reduced to 13 over 4. So it'll be 13 pi over 4. All right, so now changing from radians to degrees. So radians to degrees. So remember, what we know is pi radians is equal to 180 degrees. So I'm just going to replace pi with 180 and just simplify. So let's look at A. Negative 3 pi over 4. Well, that's going to be negative 3 times 180 divided by 4. And then you plug that into your calculator and you get negative 135 degrees. Let's look at B. Pi over 8. So that's 180 divided by 8, which is 22.5 degrees. Okay, so let's take a look at 4. Okay, so number 4 says, if secant of x minus 4 is equal to cosecant of 5x plus 10, find x. So I notice I have these trig functions, they're equal to each other. And I notice that it's secant and cosecant. They are cofunctions. And when cofunctions are equal, the angles add to 90 degrees. So x minus 4 plus 5x plus 10 equals 90 degrees. All right, we'll combine like terms. So we have x plus 5x is 6x. Negative 4 plus 10 is positive 6 equals 90. So we will subtract 6 from both sides. So 6x is equal to 84. Divide both sides by 6, and we get x is equal to 14. All right, let's take a look at 5. So 5, I have these two trig functions. Tan of 4x is equal to cotangent of 5x. So I have these cofunctions, tan and cotangent, they are equal to each other. So therefore the angles 5x and 4x are complementary. So 4x plus 5x is equal to 90. So 9x equals 90, so x is equal to 10. Okay, so let's take a look at 7. 7 says, find one positive and one negative coterminal angle to negative 415 degrees. Now remember, coterminal means they have to, oh sorry, I skipped number 6. So it says, number 6 says, find the complement and supplement if they exist. So remember, complement is two angles that add to 90. And a supplement is two angles that add to 180. Now remember, those angles have to be positive. So to find the complement of this angle, 2 pi over 11, and we want to stay in radians, so the complement. Okay, complement, I would do 90 minus my angle. So it's going to be 90, which is what in radians? Pi over 2, minus my angle, which is 2 pi over 11. Now you can't plug pi in the calculator, so what you plug in is 1/2 minus 2/11. So 1/2 minus 2/11 is equal to 7 over 22. So it's 7 pi over 22. That would be the complement. So let's see, before we go to supplement for this angle, let's do the complement of this guy here. So the complement would be pi over 2 minus 23 pi over 36. All right, so remember this is 1/2, so it's 1/2 minus 23 over 36. So this unfortunately comes out to be a negative. It comes out to be negative 5 over 36. So it's negative 5 pi over 36. You can't have a negative angle, so therefore there is no complement here. So it does not exist. All right, so let's do supplement. So supplement, the two angles that add up to be 180. So to find the supplement is going to be 180 minus your angle. So now remember, 180 in radians is pi. So it'll be pi minus your angle. So it'll be pi, let's do the first one, pi minus 2 pi over 11. So what number is in front of pi? 1. So it'll be 1 minus 2/11. So 1 minus 2/11 would be 9/11. 9 pi, sorry, over 11. Okay, and the next one, so it'll be pi minus 23 pi over 36. Remember, there's really 1 here. So it'll be 1 minus 23 over 36, which is 13 pi over 36. Okay, so let's take a look at number 7. Find one positive and one negative coterminal angle to negative 415 degrees. So remember, coterminal angles are angles that share the same terminal side. So for instance, let's say I have this angle here. My coterminal angle would be this angle. So it completes a circle. So coterminal angles are multiples of 360 degrees. So since my angle is negative 415 degrees, to get a positive coterminal angle, I'm going to have to add 360. So negative 415 degrees plus 360 is negative 55 degrees. So that's still not positive. So I have to add another 360 degrees, which comes out to be 305 degrees. That would be my positive coterminal angle. To get a negative, so I do negative 415 and subtract 360 degrees. So negative 415 minus 360 would be negative 775 degrees. Okay, so let's take a look at number 8. Number 8 says to write sine 295 degrees as a function of a positive acute angle. When it says positive acute, you have to think reference angle. Okay, so let's draw a picture. 295 degrees terminates in quadrant 4. So here's 295 degrees. So I want the reference angle. Remember, the reference angle is the angle formed with the terminal side and the x-axis. So this is my reference angle here. So I would get that by doing 360 minus 295, which comes out to be 65. Okay, so this angle here is 65 degrees. Okay, so we can't just say sine 65 because if I do sine 65 and I plug that in my calculator, it's going to be positive because 65 is actually in quadrant 1. So what I do is think about what sine is in the fourth quadrant. And sine is negative in the fourth quadrant. So my answer is negative sine of 65 degrees. Okay, so let's take a look at number 9. So it says the point 35, comma, negative 4/5 is on the unit circle. So I want to find sine, cosine, and tangent. So remember, on the unit circle, that can be written as cosine, comma, sine. So this point here, the point 3, 5, and negative 4, 5, that is in quadrant 4, right, because it's a positive x, negative y. So in quadrant 4 here, so it's over here someplace. So this point, P, is, remember, xy, and that can be written as cosine theta, comma, sine theta. So my point is 3/5, comma, negative 4/5. So remember, my x is your cosine theta, so that's 3/5, and y is sine theta, and that's negative 4/5. Now also remember this, that tangent theta is equal to sine theta over cosine theta. So sine theta is negative 4/5, and we're dividing by cosine theta, which is 3/5. So we'll do same change flip. So it's negative 4/5 times 5/3. The 5 is reduced to 1 and 1. So tangent would be equal to negative 4/3. Okay, so let's take a look at number 10. Number 10 is to expand the binomial. So the binomial is 2x plus y squared to the 5th power. And remember the binomial expansion formula. NCR, P to the R, Q to the n minus R. N is your exponent. R is your exponent down to 0. P is the first term. Q is the second term. Alright, so we're going to start with 5. So it's going to be 5C5, and then it'll be 5C4, going to go all the way down to 0. 5C3, 5C2, 5C1, and 5C0. And then P is the first term, which is 2x, so it'll be 2x to the 5th, 2x to the 4th, 2x to the 3rd, 2x squared, 2x to the 1st, and 2x to the 0. And then Q is the second term, so it's y squared to the 0. Y squared to the 1st, y squared to the 2nd, y squared to the 3rd, y squared to the 4th, and y squared to the 5th. Alright, so now let's plug it in. 5C5 is 1, 5C4 is 5, 5C3 is 10, 5C2 is 10, 5C1 is 5, and 5C0 is 1. Alright, and then we have 2x to the 5th. Make sure you raise the whole thing to the 5th power. So 2 to the 5th is 32, so it's 32 so it's 32x to the 5th. 2x to the 4th. So 2 to the 4th is 16, so it's 16x to the 4th. 2x to the 3rd is 8x to the 3rd. 2x squared is 4x squared times 2x to the 1st, and 2x to the 0 is 1. Anything to the 0 power is 1. Okay, and then we have y squared to the 0 is 1. Y squared to the 1st is y squared. Y squared squared is y to the 4th. Remember, power to a power, you multiply the powers. Y squared to the 3rd is y to the 6th. And then have y to the 8th. And then y to the 5th. y to the 10th. Okay, so now we multiply here. So I have 1 times 32 times x to the 5th is 32x to the 5th. And then I have 5 times 16 is 80, so I have 80x to the 4th, y squared. 10 times 8 is 80, x to the 3rd, y to the 4th. And then I have 40x squared, y to the 6th. 10x, y to the 8th. And then y to the 10th. And then you have to write it as the expansion. So it would be 32x to the 5th plus 80x to the 4th, y squared, plus 80x to the 3rd, y to the 4th, plus 40x squared, y to the 6th, plus 10x, y to the 8th, and then I need plus y to the 10th. Okay, so let's take a look at number 11. Okay, so number 11 is to factor 3x to the 3rd minus 81. So I'm going to first factor out the GCF, which is 3. Then I have x to the 3rd minus 27. So this is the difference of perfect cubes. So I'm going to use SOAP. So remember, the S in SOAP stands for same. So it's the same sign. O is opposite signs. A is always. And P is positive. Okay, so I set up my 2 parentheses. Hopefully you remember this. Right, so it's the same sign, which is negative. Opposite sign, so it's plus, and then always positive. Inside the parentheses is AB. And then it's A squared, B squared at the front and end of the second one. And in the middle is A times B. So now we need the A and the B. The A is the cube root of x to the 3rd, which is x. And B is the cube root of 27, which will be 3. So it will be x minus 3 times x squared plus 3x plus 3x plus 9. 3 squared is 9. And don't forget you have a coefficient of 3, so you have to bring that down. All right, let's take a look at the last problem. All right, so we want to be able to graph this without a calculator. So this is a rational function. So the first thing I'm going to do is to factor and try to clean this up to see if there's any holes. So I notice I could factor the denominator. The numerator just stays as x minus 2. The bottom is x plus 2, x minus 2. So I notice I have the same factors here. The x minus 2, x minus 2. So that reduces, so that's my hole there. So this becomes 1 over x plus 2. So this is my cleaned up version. My cleaned up version is f of x is equal to 1 over x plus 2. So let's start with the hole. There's a hole at x is equal to, so this would be x is equal to positive 2. So how do we get the coordinate? So x is 2, I need the y value. So I do f of 2 and I plug it in here. So it's 1 over 2 plus 2, which is 1/4. So that's my y value, 1/4. All right, so I need my vertical asymptote. My vertical asymptote would be when this now is equal to 0, the denominator. So that is x equals negative 2, and it has to be x equals because it's an equation of a line. I need my horizontal asymptote. So I compare. So you could look at this, or I could look here. There's no x in the numerator, so that means my denominator is growing faster than my numerator. So remember, when the degree in the denominator is greater than the degree in the numerator, that is y is equal to 0. Slant asymptote, that does not exist. So if there's a horizontal, there is no slant. You can only have a slant if there's no horizontal. All right, so I need now my intercepts. So my x-intercept, remember, is when y is equal to 0. All right, so I'm going to make y equals 0. I could plug it into the cleaned up. 0 equals 1 over x plus 2. When I cross multiply, I get 0 equals 1, so that doesn't make sense. It does not exist. And now I'm going to do my y-intercept. That's when x is equal to 0. So y is equal to 1 over 0 plus 2, which is 1 over 2. So it's 0, 1/2. All right, so now we're ready to graph. We'll start graphing anyway. Okay, so let's start with the hole. I have a hole at 2 1/4, so it's about there. I have a vertical asymptote at x equals -2. I have a horizontal asymptote at y equals 0, so that's right here, right on the axes. Okay, and then I have a y-intercept at 0, 1/2, so that's about there. All right, so I make a table of values to find some other points. So I'm going to use, in my table of values, I'm going to use -4, -3, -1, and 1 because I want to see what's going on. So I plug these numbers into the cleaned up version. So I have 1 over -4 plus 2, which is 1 over -2, so it's -1/2. Okay, so I'm going to plot that point. So I have -4, -1/2. And then I'm going to do -3. So I have 1 over -3 plus 2 is 1 over -1. So that's -3, -1. So I can see what's going on here. My graph is looking like this. And now I'm going to plug in -1. So it's 1 over -1 plus 2, which is 1 over 1. And now I'm going to just finish up at 1. So I have 1 over 1 plus 2, which is 1/3. So it's like right there. So then this side looks like this. Remember, don't go through the hole in the graph. Okay, so that's it, and I'll see you guys tomorrow in class. Have a good night.